Bismillahirrahmanirrahim. Assalamu alaikum. Dear student, today we discuss intermolecular forces and hydrogen bonding from chapter 4 structure of molecule. Before going to discuss intermolecular forces, first we describe intramolecular forces. The intramolecular forces are the force of attraction between the atom. These are strong force and depend upon polarity of molecule. Polarity, the degree of separation of charges. These intramolecular forces are present in ionic bond between positive and negative charge. They are very strong. For example, in sodium chloride, covalent bond due to sharing of electrons between the atom, metallic bond between the positive and negative ions of the metal. The intramolecular force of attraction exists between the atoms, and these are strong force of attraction, and the strength of attraction depends upon the positive and negative charge. Now, intermolecular forces. The force of attraction between the molecules of a compound are called intermolecular forces. And intermolecular forces are weaker than intramolecular forces. Intra are between the atoms. Inter are between the molecules. Collectively, intermolecular forces are called van der Waals forces, and there are three types. London dispersion forces, they are the weakest one in intermolecular, dipole-dipole interaction, and hydrogen bonding. These intermolecular forces are present in polar molecule. We have already described in our previous lectures what are the polar molecules. For example, first we discuss the London dispersion forces. It is the force of attraction between the temporary dipole caused by the movement of electron in the atoms of molecules. In some molecules, the electronegativity may not be very strong, but their electrons are continuously move about, and sometimes they may be moved toward one side of the molecule, and they will create a side by the movement of molecule, one of them positive and negative, but this charge is for some time, and we say that this is the temporary charge. For example, let's see iodine molecule. When it creates this dipole, then one of and become partial negative and the other become partial positive, and this force of attraction for the temporary time is known as London dispersion forces. Now, dipole-dipole interaction. The attractive force between the positive pole of one polar molecule and negative pole of other polar molecule are called dipole-dipole interaction. Polar covalent molecules are sometimes described as dipole. In polar, one of the end of the pole is positive and the other end of the pole is negative. The molecule have two poles. One has a partial positive charge while the other has a partial negative charge. For example, in carbon monoxide, nitrogen oxide, HCl, H2S, H2O, and NH3. Now, we describe the dipole-dipole interaction with the help of an example. For example, HCl is a polar molecule with the partial positive charge on hydrogen and partial negative charge on chlorine. These partial charges attract each other due to electrostatic force of attraction, which cause dipole-dipole interaction. For example, let's see the molecule of hydrochloric acid. Hydrogen carry a partial positive charge, and due to more electronegativity, chlorine carry a partial negative charge. This is a polar molecule. These are the other molecules of HCl. Now, how this dipole-dipole interaction occurs in these molecules? Let's see. The positive pole attract the negative pole of the other molecule. This is called the dipole-dipole interaction. This is not a true bond. This is just the force of attraction between the partial positive charge of a one molecule and partial negative charge of the other molecule, and this force of attraction is known as dipole-dipole interaction. The force of attraction between the atoms of hydrogen and chlorine is much more strong than this dipole-dipole interaction. The force of attraction between hydrogen and chlorine is 434 kilojoule, whereas the dipole-dipole interaction between the chlorine and hydrogen molecule is 3.3. Therefore, it can boil at minus 85 degree Celsius. Now, hydrogen bonding. It is the force of attraction between highly electron deficient hydrogen atom and nearby highly electronegative atom with lone pair of electrons such as nitrogen, oxygen and fluorine. Due to large electronegative difference, result a strong positive charge on hydrogen atom and negative charge on electronegative atom. Molecules in which hydrogen is covalently bonded to a very electronegative atom, that are fluorine, oxygen and nitrogen, then a strong positive charge is developed on hydrogen atom due to large difference of electronegativity value. As a result, the strong force of attraction is developed between hydrogen and these electronegative atoms, and they make a bond known as a hydrogen bond. For example, water is a polar molecule with a partial positive charge on a hydrogen and partial negative charge on a oxygen. These partial charges attract each other due to electrostatic force of attraction which cause hydrogen bonding. Let's see. This is a water molecule. Oxygen, due to more electronegativity, it carry partial negative charge, and hydrogen carry partial positive charge. Now the force of attraction between the partial positive charge of one of the hydrogen atom with the other molecule of the oxygen atom is known as a hydrogen bonding. And hydrogen bonding is a strong force of attraction amongst the intermolecular force of attraction. And due to this strong force of attraction, water has some unique properties due to the hydrogen bonding. For example, hydrogen bonding is important in many chemical processes. Hydrogen bond hold complementary strands of DNA together, and they are responsible for determining the three-dimensional structure of a folded proteins, including enzymes and antibodies. The adhesive property of water is developed due to hydrogen bonding. Similarly, substances like glue and honey are sticky due to the hydrogen bonding. It is also very important in thread making material like cotton, silk and synthetic fiber for clothing. Properties of hydrogen bonding. Hydrogen bond is 10 times stronger than dipole-dipole interaction and 20 times weaker than covalent bond. Because it is not a true type of a bonding, but due to the presence of a more electronegative elements such as oxygen, fluorine and nitrogen with lone pair of electron, make them this force of attraction strong than dipole-dipole interaction. But as it is not the ordinary type of bond like ionic covalent, so it is 20 times weaker than a covalent bond. Hydrogen bond is directional. It forms long chains and help in the formation of network of molecules. Now at the end there is quiz for you. What is the difference between intramolecular and intermolecular force of attraction, and what kind of force of attraction is present in water, ammonia, chlorine, hydrogen fluoride, hydrogen sulfide and methyl alcohol? This is the end of our lecture. Allah Hafiz.